Right, so in this session we're just going to cover static members, static variables and members within a class, and compare and contrast them to instance variables and members. So there's a few test classes to go through in this package, but this one's just going to introduce the basic concepts, and then some of these other packages are going to go into them in a bit more detail. So we've got this. So what we've got some Java docs in this class here, and so we've got three basic usage of static members, static variables and methods in a class. First one, we're quite used to doing that now. It's to provide an entry point into a program without requiring an instance or a class. In other words, the main method. So the main method is static, which means you can launch a Java program without creating an instance of it. Then once it's created, it then can of course create instances of things, but you need to start it without an instance to begin with, so that main method is a good way of doing it. And usually you find static methods are like kind of utility or helper methods that don't require an object state. So we've seen a few examples of those in those date classes, where you'll ask for a date and have a date returned back to you. And that's because that class, those date classes, they don't need to know any state about about anything else like usernames or dates or anything like that. They just need to get the system date and pass it back to you. So that utility methods can be static, like owned at the level of the class. They don't need to know any state of any individual object. So we'll look at some of those in a bit. Also mentioned here that another example of it is this class that we use ourselves, this animal list data manager we've used in some of our demos. So if I just go and find that one, there it is, there. What that does, of course, is it creates these lists and maps of animals and things, and then it provides these static methods on how to get some of them. So if somebody asks for an animal of this name, it's got out of that list and returned back again. Or if you want the whole list, it's returned here. So this class here is not concerned with the state of anything, with any particular instance at the time that you ask for that list. It just sort of blindly gives you that list. Of course, the objects in the list have their own state and things, but this is like a wrapper of those classes. So you get this static list, it just returns the list. It doesn't care who you are or what you are, what time it is. It doesn't require any state to do that. It just gets this list and chucks it back at you. So they're utility static methods. Yeah, so the other usage, so that's two of them, and the other one is where you do have a state, where you do require a state, but that state is shared by all instances of a class. So the classic example we've already looked at is like a web counter, or a counter on, and monitoring how many of a certain object you're creating. So you can use it where you don't need any state at all, like this example, like just grab me a date and give it back to me, or give me the number 5 and take it back to you, so you don't retire depending on any state, or where you are depending on state, but that state's common for all members of the class. So it's like class level state rather than object level state. So a counter is an idea. We'll have a look at some of these in a second as well. Like we've already seen, like this is an example here, zoo, animal, zebra. You'll notice you're getting quite a few more animals in this package here. So most of these animals in here are just bog standard animals that extend that class, and they're just sort of there to kind of make up the numbers, if you like, so we can populate that zoo. There are a few special cases. So I think we had this one in the session where we were looking at inheritance and access modifiers here. This duck one, and I think it's it's zebra. Sorry, this is the zebra, which is a special case. But they still extend animal, so they're still members of this class, but they sort of do their own thing. This one is a special version of this that is used to be used in static demonstrations. So this in itself demonstrates like how inheritance works, because they all inherit animals, so they've got certain characteristics in common with animal. But they're all different as well. So like zebra, for example, is quite geared towards demonstrating static methods, whereas duck is geared towards demonstrating inheritance. So, but anyway, So yeah, this class animal, this class zebra, sorry, it has a count variable and it's static. So that means it's owned by, if you have 100 instances of this class, there's still only one of that, still only one of those. And every time we create a zebra, we increment it. So it's just keeping an internal count of how many instances of it you're creating. So that's basically that method here. And we've got get, and anything that interacts with that static variable is also static. We're also static by convention. Just see if there's anything here that we can come back to. Yeah, well, for example, we have just to show how it works the other way around. We'll go into this in more detail in a minute, but here's a method that tries to return the name, and this name. So this is a static method, but name is, and of course we can't see name there because it's defined in the superclass. Name there it is, but that's actually not static, it's instance. So we could just make it static like that, and it's private. Yeah, there's another thing as well. It's private, so it would have to be like protected, for example. There. In fact, let's make it public. There we go. And then you can get. Let's just save that. Save all. So then it is accessing it. We've got other errors here because we've got two versions of the same method there. But you can see now it is actually accessing that now. But of course we don't want to make it static. We don't want to make name static because that is very much a candidate for an instance variable because it has state that is relevant to just a single instance. So every animal has their own name. Would be no point if they all had the same name. So just revert that to back to what it was again. There we go. That's it. So that was, I kind of got a bit sidetracked there. We were just yeah. There we go. Those three usages for static methods, and also it's better to bear in mind as well that when they're used, that they kind of save. They save space on memory because you don't have to create instances to call them, and they save lines of code as well because typically they're quite easy to call. You just call them from the class name. So this is going to introduce some of the concepts here. I mean, a logger, our logger that we started using, that's static. So we've got a logger, and that means that every instance of this class, when they call a logger, they're all calling the same one. So all the log entries are nice and neat and coordinated in the same file. A major use of static variables is for use of representing constants. So here we've got the start date of the French Revolution here, and because that's never going to change, it's always going to be that date. We can make it public, static, and final. So it's like a constant. So major use of static variables is for representing constants. So where you need both these two together, like that. You could just make it non-static if you want, like that. But it's better if you can make it static because otherwise, if you didn't, and any other classes wanted to use it, they'd have to first import your class, then do a new instance of your class, and then get it through an instance. So much better to do it like that. Then they can simply get it using the name of your class. A couple more here of static variables. So 100 is just a representation of 100 because again 100 is never going to actually change. So you can make it static. You could make it final too. I just haven't bothered in this example. This one is an instance variable. Day of the month is 5. So day of the month can change, of course. But at the moment we're saying it's 5. But that can, of course, change. So there's a few variables there which we'll look at. We'll call down here. So here we're calling these now. We're saying French Revolution started on and then referencing that variable up here at 100. So we're calling that. But what we can't do is we can't call that day of month there because it's an instance variable. So what we're saying here is at a static level, at the level of the whole class, print me this variable that's only relevant to an individual instance. Day of month's not a very good demonstration really, because of course day of month could be relevant to all members of the class, but if it was somebody's name, for example, that illustrates it better. If this was a person and this was their name, that illustrates much better why that wouldn't be appropriate to put here, because of course everyone has a different name, and this is something owned at the level of a class. So that's right. And so what you would do if you wanted to, say you did want to reference that day of month, you'd have to actually create an instance of a class there, and here we can reference it. And that makes sense, because here you're saying, well, I can't reference that at some abstract level. I have to get an actual instance here. So again, if these were people, say this represented an actual person, this represented Jim Smith, then you can call instance methods, because those instance methods refer to the state of that actual person, that Jim Smith in that example used there. So you can access instance methods from a static context, but only through an object reference, just not directly like that. So another thing to say is that you can call static methods by the name of the class. So we've already mentioned zebra here, so we can call these methods purely by using the name of the class, because we don't need to make an instance of it. And one of the methods we can call it is actually the main method if we want to. We're not used to doing that, because when you used to call it, we're used to calling that from an IDE or command line, but we can actually call it programmatically if we want to. And just to show here, of course, we can't do it like that with empty parameters there, because the main method requires the args array. But if you don't have an args array, you can just, of course, pass null into it, and that'll work just fine. Or you can pass your own new array in there if you want to. Or, as you remember, you can do it with like var args if you want to. If your main method takes var args, that's the ... notation. But if we look at this zebra here, the main method of zebra, all it's going to do is tell it that, do us like a log statement to tell you you're in the main method. So even though you're passing in args to it, they're completely ignored. So we're calling zebra there, so that's fine. And zebra has a static count variable. So this is what we were referring to before. We were saying that, as zebras, we want to monitor how many zebras we're creating, putting in the zoo. So we can print at any time. We can print what that count is. There we go. So again, if that wasn't static, then that method there wouldn't compile, and you can see that wouldn't compile because it's considered an instance variable. I see in various places the compilation's now failing because you're trying to access an instance variable from a static context, but put it back in and it all works fine. So going back to the test again, so we're creating these zebras here and printing the count. Now, as this is revision, I won't sort of print all these individually. I'll just sort of talk through it, then we can just run through it once and look at the results. Here we're creating some different instances of that zebra, so Zane and Sue, printing again at each time. What this demonstrates is, so the pattern we're getting here is that static methods you call through the name of the class like that. So that's the way you do it. You can, if you want to, call it via an instance. So this print count method here, we're calling it via the class name there, which is the right thing to do. But here we're calling it through actual instances. It still works, as you can see. It still actually works fine. It's just not considered best practice. In fact, we've even got because we're using an IDE here, it's even giving us a sort of, it's not an error, but it's like a warning or an advisory. It's kind of saying this method print count is accessed via instance references. So the IDE itself is flat, and that's why they're in yellow, I guess. It's trying to say this isn't best practice. But you can do it if you really want to. But I think it's misleading and just not best practice to do it.
You're still going to get the same value though, aren't you?
Still going to get absolutely the same value. It still works absolutely fine. Absolutely fine. It's just a convention, really. In the same way that we use a certain convention to name variables and things. It works fine if you don't use those conventions. It's just it would be picked up in a review and it would be considered not best practice. Same here, really. But it's still, you're absolutely right, it's still perfectly valid, gives the right answers and everything. So we created another one here, Joe, and again we're calling that same method, here the proper way and here through the instances. So just comparing and contrasting that. And so what we've got here, but again, we're reiterating points over and over again. So the reverse is not true. So print my name on the Zebra class is a non-static method. So print my name, there it is, that's non-static. So to make that line that we just added work, we'd have to use this method here. We'd have to like put static in there. So static in there, static. There we go, static in there. Now we have the problem, of course, that that's not relevant. But just in the terms that, but that now compiles here for that reason. Print my name. But I'll go back because that's not what we want to do. It's just to illustrate the principle. So we're a lot of these principles just repeating over and over again, just to make them because they're quite complex when you first see them, or quite maybe not intuitive. So that's the same one. Yeah. Okay. So I'll just yeah, those are in debug because I want to do that one later. So I'll just run that as it is now. Static member class here. So. And you can see like the various things we looked at as we came through. We called the main method of the Zebra class. Those were constants we were using there. We can see this is creating a count of the instances we're creating here. The only reason we've got various ones, various different printouts of that is that we were just demonstrating that you could do it through an instance or the class name itself there. Like, so you've got 4 printouts there, 4 printouts there. Fact is, whether you do it through an instance or the proper way, you can see that it's you're getting consistent results there. So every single one of these instances and the class itself had a value of 3 at that point because 3 instances had been created. And here, when we printed my name, well, these were instance methods. So it worked like that. If we just change that to static, like that. And in fact, we have to do less refactoring if we comment this and uncomment that one. A bit less refactoring then, because then all we have to do is go to the animal and make that static like that. And then, oh yeah, of course, it has to be. So we're seeing all the different elements of things we've covered in the past now. That has to be public now, or at least, but not private at least, for Zebra to be able to see it, which it now can. So if we run that test again now, static member test there. That again. So you'll see that method, we called it through 3 different instances, but it's the same for all of them. It's set to whatever the last one set it to. So obviously we don't want that happening. So we'll just comment that out and put it back in the right way again. So there we go. And animal. So that. Make that private because we're doing encapsulation here, private. So that's that one. And then just to show how using static members kind of saves you time and effort. Really, we've got 3 different ways here that we're going to get to today's date. So so we've got in this package here, date retrieval. We've got 2 classes. One that gets a date the instance way. So it has itself a date variable which gets initiated to right now. See, that's a static method in itself. You can tell that because it's calling it directly from a class name. Then a getter on it that simply returns it. There's a setter as well because this is a convention. We don't really need it because we're not using it, but we put it there anyway because this conforms to a classic encapsulation or a Java Beans standard, a private method, and then a getter and setter. So, but anyway, that's the first one. So the second one, we're just going to as that's a static method itself. We don't really need to bother with most of this. The static version of it just does this. It just says just return local date now. It's a static method rather than an instance method, but just get local date now and return it straight away. So you can see it's much less code than this one, much less code than that one. And in the tester, we've got to call the first one. We have to, as it's an instance method, we first have to create a new object. So it's it's creating an object, and B, it's 2 lines of code. The second one, we just have to call that method directly from the class name. There is a third way, which is you don't really need either of those classes. You can just call that directly. So that's even better, because it's calling all of these directly. But if we change that to info, it should all give the same answer, but there's different ways of going about it. And use of static methods is encouraged where you can, when you're not relying on individual object state, because for those reasons it cuts down on code and object references that you need to make to do it. There we go, same answer but 3 different ways of doing it. So as we mentioned, final static variables are a very good way of a very, very common way of representing constants in Java. So we already did the start of the French Revolution in our other class, but it's repeated again here just because obviously it's something that's not going to change. If something's not going to change, you might as well make it final. And if you want to share it amongst other classes easily, make it static. Then they can just get it by reference to your class name without having to create a new object reference. So there's just a few examples of some constants there. One thing to note here is that the naming convention changes when you use constants. You tend to use all capitals separated with underscores, because you might expect that one is string here. You might expect that would be the normal convention, like that, camel case. But when it's constants, things that are public, static, final, then we use this convention like that. And these tend to be very descriptive as well, very, very much, because they might be used by all over the place by client classes that don't even know who you are or where you're from or whatever. So they have to be quite descriptive. And the very fact that they use this convention, any user of them realizes, oh yeah, this is a constant. It's not like this. It's like that. So it's a constant. So you can reference these constants easily in the same class just by using the same name like that. Referencing constants. Referencing constants in other classes, well, you can do it by referencing the class name and then that constant. So we used to like calendar class is the Java standard before the local dates came along. So that has some constants in it. If we look at the calendar class, the actual Java calendar class, you can see there's lots of these public, final, static things that aren't going to change. So how it represents a year as an integer 1, it represents a month as integer 2, etc. And these aren't going to change. Individual months, there we go. So like day of a week. So you can see all these date related public final static things in the calendar class. They're all defined there. And if we go to the date class, which you're more familiar with, you can see that. So this is local date, one we covered a few sessions ago, end of chapter 3. This also has lots of public final static variables here, like the max. What's this one? It's like the max value of a date and minimum value of a date, minimum, maximum. There you see things that aren't going to change. But then what we come down here to instance variables. So they don't have static in here. They're instance variables because it's a year, a month, and a day. So this is for a particular instance of a date. So if we did local date.now, these will be populated with right now. And notice that they're still final. What that means is that once you've set them once, you can't change them again. So the date class, like string, is immutable. Once you've set it, you can't change it. If you do want to do date manipulations in the way we did in chapter 3, new objects will be being created in the background. But just a demo there of final static variables as constants. One other thing to note as well is that you might have something that is, so this is a constant string array list here. So what we've said is it's private static final, so you can't change it. You can't change that reference once it's been assigned because it's final. You can only ever do it once. But actually you can. That doesn't mean that you can't still do things with it. So for example, I'm adding here it's a list. It's a list, that particular variable. It's actually an array list, which we've already dealt with. I'm going to add something to it. Now that's absolutely fine. I can add things to it, take things away, iterate through it, print from it, whatever. The thing that can't change is this object reference here. So what we can't do is that, because that's final. We can't assign it to a new object, but it doesn't stop us actually using it. So that's one thing that's quite worth memory. So you can change the state of that object by calling its methods. You just can't reassign it to another variable there. So that's final static variables. Imports is another one. They seem to be quite keen on putting these in exams and study guides. They always have, even though in my experience they're not particularly important, I don't think, to know about these, but we'll go through it anyway. So this is talking about static imports. We've already done a bit in chapter 1 on actual import statements, like whenever we use classes that aren't in java.lang or our own package, we have to import a class. So there's loads of stuff here that's commented out. We'll just concentrate on what isn't for now and gradually comment those other things out. So what we've got here in our main method here, we're creating a list. And you remember that from, I think, chapter 3. There's a static method on this arrays class to give us a list. And you can pass in what you want making into a list here. So we briefly covered that method when we were talking about arrays and collections classes and things and array lists. So that can pass fine, but it only compiles because we've got these imports here. If we take these away, of course it doesn't compile anymore. Neither that compiles nor that, because it doesn't know what it is. So put them back in. And we're calling that as list method direct on the class name, the static way of doing things. But what you can do, you can actually call that as list method without the arrays, without referencing the class. So if I make my list 2, we can call that directly. But to do that, we have to actually do a static import purely of that method. So there we're doing import stat. So we're importing a static member there. As list is a static method in arrays, which we're also importing the whole class there. So we could import the static member like that, and that now compiles. And if we wanted to do it that way, of course, we could get rid of the first one and get rid of that, and it works fine. So rather than importing the whole class, we've just imported a static member. Like that. As I said, it's worth knowing that, but you rarely see developers particularly bothered about that, or particularly keen to do that, or making a point that, oh no, we don't need to do that, it's wasteful, we'll just do that because we're only using that one method. I don't think there's much overhead in just doing that, and then you've got it there. But then, of course, to make that compile, you would the only thing in not doing it, you would have to use the class name like that, and then it works fine. But you can do a static import, just a static member like that. So you can't. So we've imported that. What you can't do, you can't import that whole class statically like that. So that's the same class. You can't do import static like that. You can only import, because various parts of that class won't be static. You can only import the individual members that are static in it. So we can't do that. We have to, if we want the access to all that class has to offer, we just have to do that. This shows about, again, chapter 1 I think it was, we talked about clashes in import statements. This is just another demo of that at a static level. So we've got these two classes here called A and B. Can I open that as B? Their only purpose in life is they both hold a single variable there, both called type. So type in A and type in B there. So if we go to our tester again, so what we could do if we wanted to, we could statically import those. So we can go do that, b.type, and a.type. So now it complains because it's saying, oh, hang on a minute, you're importing two things called type. Now that's going to cause ambiguity, because if in the body of your method here you try and reference type, we won't know which one it is. There's a clash, and I remember in chapter 1 we had a clash, and it was around the date classes, java.util.date and java.sql.date. Very similar thing, that you're importing something with the same name. So any way you can really get rid of it, you can just, what you can just choose to import one of them, the one that you think you're going to use most, and then for the other one, so that's fine there. So for the other one, you just have to, you have no choice but to just call it directly from its name. So we said we were going to call in A. So for B, we have no choice but to do that. This will default to A because we've statically imported it. This one we're explicitly telling it, no, don't use the type we've imported. Use the one on B. One other thing you may have noticed, we haven't actually imported the class B here. That's simply because we're in the same package as it here. So we can call the name, we can call B without actually saying, import me class B here. This is just the import of a static member. So all that really does is illustrate that as well as importing classes in a normal way like that, you can import anything that's static within that class. You can do a static import. They've always seen, because I've been doing these Java certifications since Java 1.4, they've always seemed to be keen to include that. Although in practice in the field, we rarely see people paying too much attention to this, in my experience at least. But you just need to know about it, really. So final thing on statics is visibility of them, really. It's just a revision of what we already did in the first test class, really. So this one is a class. It's got a logger. It's got a static field, static string, and it's got an instance field, instance string. And in a static method, you can call the static members there. So this method is calling that, yeah, you can see it's actually calling itself. That's perfectly okay. Static method is calling itself. That's a self-reference there. That's okay. But you obviously want to avoid that because it can go to doing infinite looping. But it's actually syntactically okay to do it. This is just a demo class, really, to show a principle. You wouldn't normally want to call a method on itself unless you're very careful about it, because it can just go into an infinite loop. But just a demo class to show that we can't do that or that. Again, it's just a revision of what we've talked about many times, because the instance methods can't be accessed from a static context, because they're only relevant to an actual instance of something, like someone's name or someone's bank account details or whatever. They make no sense at a class level. But if we do, again, a revision, if we do want to get hold of these two instance members, we can do so through a genuine instance of the class here, a genuine instance of the class that has state. So these will actually mean something in reference to an actual object that has state. Imagine that was someone's bank account. That would have an actual bank account number, an actual username, all the rest of it. So these will make sense, but they don't make sense at a static level, so you can't do it. But the reverse is not true. So from the instance method here, so this isn't a static method, this one is, you can call both the static method and variable and the instance method and variable. So it's fine this way around, but as we said before, it's not good practice to call static methods through an instance. And I'm saying discuss the two ways to get round instance access within a static method. Well, we've already done that. One way is simply to create an instance like that, and then you can get access to them. The other way would be to make the variable itself static, if I made that static. But then, of course, that has implications. Do you really want to make it static? Because it'll then be at a class level. You might make it make it thread insecure or thread unsafe. I think the Gorilla class here, this is taken from an example of the book. It just hammers that point home again. Won't go into it in too much detail, but it's got a static and a non-static method again. And from a instance context, you can call both of them. From a static context, you can only call the static one. So it's just hammering that point home again and again and again. So that's pretty much everything on statics, really. And they're where I tend to see them used a lot is on classic kind of utility methods. Say if you just want a date, or you want to send in a string and have it formatted in a certain way, it'll send it back to you. Things that don't depend on any external state of individual objects. They're very handy methods to use, and it's quite easy to use.